Now our task is to simplify square roots. So we'll start with this guy here. And the story is this. Look, anytime you take the square root of a times b, you can break that up into one factor of the square root of a times another factor of the square root of b. Now, keep in mind, if you have the square root of a plus b, then there's nothing you can do with that. That just equals the square root of a plus b. Those do not break apart. So, now let's get on with this. So 5 times the square root of 16 times 2. Now notice, 16 is a perfect square, so we'll do this the long way. 5 times the square root of 16 times the square root of 2, and that equals 5 times, and the square root of 16 is 4, and root 2 is just root 2, and so that equals 20 root 2, and we're done. Well, our next square root problem goes like this. Let's see, we've got 8 times the square root of, and 112 is the same as 16 times 7. 16 times 7, and we've got this p squared here. So that's going to be 8, and we know that the square root of 16 is 4, and the square root of p squared is p, and we're just left with the square root of 7, and there's nothing we can do with that, so 4 times 8 is 32. There's our friend Mr. P, and square root of 7, and we've simplified it. And now we have one more of these problems, and let's see, 2, and the factors of 72. Are there factors of 72 that are perfect squares? Well, it turns out 36 times 2 is 72, and we still have this x squared and y squared. Now the square root of 36 is 6. The square root of x squared is x. The square root of y squared is y. And what remains under the radical? Well, Mr. 2 does. And now we'll simplify this. We get 12xy square root of 2, and we're done.